China just cut off ASML and TSMC for good. On April 12, 2025, Beijing formally terminated all procurement contracts for ASML's lithography systems and TSMC-based chip orders across state-linked firms, signaling what analysts at Bernstein called the most decisive pivot in semiconductor sovereignty since 1987. The move followed a year-long buildup of localized fabs, with China's SMIC ramping DUV-based production capacity to over 300,000 wafers per month, double its 2023 levels, according to IC Insights. For ASML, whose EUV systems account for nearly 70% of its gross margin, the implications are immediate. UBS analysts report a 12% drop in advanced tool bookings from Asia in the first quarter of 2025. TSMC, meanwhile, faces a strategic dilemma. Its $100 billion U.S. expansion, hailed by Washington as a national security win, has turned into a geopolitical constraint as Beijing blacklists its nodes above 7 nanometers. Yet the real shock isn't China's withdrawal. It's the fact that they appear ready, and what they've built instead could make Western sanctions look like outdated scaffolding on a tower that no longer needs it. When Washington imposed sweeping restrictions on Huawei in 2020, cutting access to TSMC's advanced nodes and ASML's EUV lithography, it triggered what Credit Suisse later called the most expensive forced innovation cycle in modern tech. Within 5 years, Huawei and SMIC responded with the Mate 70 Pro, powered by a domestically manufactured 7-nanometer chip fabricated using deep ultraviolet lithography and self-aligned quadruple patterning. No foreign tools, no imported wafers. The chip, analyzed by Tech Insights in February 2025, showed a transistor density 17% below Apple's A17 Pro, but functionally competitive in AI inference benchmarks. The Ascend 910C followed, built to rival Nvidia's H100, and entered volume production in March 2025 at Huawei's Qingpu facility. Bloomberg confirms that over 30 domestic AI firms signed supply agreements in the second quarter alone. This wasn't a workaround. It was an architectural inversion. And if China's next move succeeds, it may no longer be playing catch-up. It may be changing the direction of the race itself. SMIC's quiet bid to reach 3 nanometers without access to EUV has triggered a fracture in expert consensus. On one side, analysts at TrendForce argue that without EUV, the multi-patterning complexity required for 3-nanometer nodes makes commercial yield rates virtually unachievable. On the other, teardown data from a prototype SMIC wafer leaked in April 2025 shows a reported critical dimension shrinkage to 34-nanometer gates, bordering on 3-nanometer territory when using quadruple patterning. The cost. Production time nearly triples, and reported wafer yields hover around 40% according to IC Lab Asia. But Beijing isn't aiming for Western efficiency benchmarks. It's targeting volume resilience. With state subsidies offsetting fabrication losses and demand guaranteed by domestic AI and defense projects, SMIC's strategy may not be economic in capitalist terms, but geopolitically, it's precise. Morgan Stanley's March report warns that China no longer needs to match TSMC's cost structure. It only needs to scale a minimally viable alternative faster than we can sanction it. Nvidia's exit from the Chinese AI market in late 2024, driven by US bans on its H100, H20, and B200 chips, created a vacuum worth over $7 billion, according to Reuters. Huawei didn't hesitate. In May 2025, it began mass shipment of the Ascend 910C, a chip engineered by fusing two 910B dies in a 2.5D package to rival Nvidia's Tensor performance. While not a monolithic 5-nanometer breakthrough, the architecture achieved 75% of H100's performance at roughly 55% of the cost, as noted by China AI Tech Watch. Huawei sold out its initial batch to state-backed cloud firms within 11 days. More significantly, SMIC's production line, using DUV lithography and adjusted SAQP, or self-aligned quadruple patterning, achieved a 56% yield rate by mid-May, up from 31% in January. This isn't technical parity. It's strategic asymmetry. Huawei doesn't need to match Nvidia on every metric. It only needs to supply chips that are good enough. And on time. The AI war just found a new front line, and it isn't in Silicon Valley. By the second quarter of 2025, more than 82% of components used in China's sub-10 nanometer chip production were domestically sourced, according to the China Semiconductor Industry Association. SMIC's new mega fab in Shenzhen, completed in just 16 months, now produces 45,000 7-nanometer class wafers every month. Meanwhile, Shanghai Microelectronics Equipment, or SMIC, hit its first production run of 28-nanometer capable steppers in March, while setting its sights on 14-nanometer by late 2026. On the personnel front, over 1,500 engineers from TSMC and UMC have reportedly accepted multi-year contracts in mainland firms since 2022, lured by compensation packages averaging 2.3 times their previous salaries, according to Nikkei Asia. Beijing's $47 billion chip fund, restructured in 2024 under CSASI oversight, has prioritized vertical integration over global interdependence. Unlike ASML, which relies on Carl Zeiss optics and German photonics for key modules, China's ecosystem is converging, slowly, but methodically. If this continues, the biggest risk to Western chip dominance won't be espionage or leakage. It'll be irrelevance by redundancy. In February 2025, a leaked engineering document from China's State Key Laboratory of Laser Technology stunned semiconductor analysts. A prototype blueprint for an LDP, or laser-induced discharge plasma, EUV source claiming a 90% reduction in power consumption compared to ASML's LPP, or laser-produced plasma, systems. According to the IEE Journal of Photonics, this new design replaces ASML's twin laser tin droplet system, where less than 0.1% of energy converts to usable EUV, with a staged dual-input approach using a low-power ionizing laser, followed by high-current electrical discharge. Engineers at Applied Optics Beijing say early lab tests produced EUV light at 13.5 nanometers with a 0.8% efficiency rate, 8 times higher than current Western systems. Though, durability under fab-scale throughput is still unproven. The real disruption isn't just theoretical. If scaled, this would remove the need for ASML's 170 million euro EUV units, which consume over 1 megawatt each. A single leak shifted global investment narratives. But really, how close is China to turning a blueprint into a functioning machine? ASML EUV supremacy is built on a manufacturing process that, honestly, burns more energy than it prints wafers. A full-capacity EUV line draws the equivalent of about 1,200 average U.S. homes per month, according to data from the International Energy Agency. The LPP method demands 50,000 laser pulses per second, with massive heat mitigation infrastructure and mirror arrays that degrade after just 20,000 wafers. In contrast, China's proposed LDP configuration bypasses tin vaporization entirely, instead generating a stable plasma through electrical discharge that emits EUV at near ambient thermal load. Chen Wei, a former engineer at Zeiss SMT who now consults for Asia Lithotech, told Bloomberg in March that if this works at industrial scale, it will shatter the precision energy trade-off we've lived with for 15 years. ASML declined comment, but in April it slashed its 2025 EUV shipment forecast by 18%, citing regional procurement uncertainties. Quietly, they've begun redesigning their own next-gen source architecture. What's behind that pivot? The pressure isn't theoretical anymore. TSMC's 2025 Arizona fab isn't just expensive, it's exposed. With $6 billion in subsidies and joint output agreements tied to U.S. national security clauses, TSMC must now prioritize Washington's directives over neutral market logic. ASML, whose core optics depend on German export licenses and Japanese photonics, finds itself triangulated between Dutch regulation, American pressure, and Asian customer loss. In the first quarter of 2025, TSMC's foundry utilization rate dropped to 76%, down from 89% in the same period last year, largely due to Chinese contract exits, according to TrendForce. Meanwhile, Canon's newly commercialized FPA-1200 NZZ2C DUV system has gained market traction as a non-aligned alternative, shipping 27 units to Southeast Asia in the past 5 months. ASML's dominance isn't yet broken, but its moat is evaporating. And for both Dutch optics and Taiwanese wafers, the problem isn't just that China left the table, it's that others are now taking its seat. Despite the headlines, building an EUV system is not the same as running it at 30,000 wafers per month with 95% uptime. China's LDP project still faces the barrier of ultra-high reflectivity mirrors, each with over 100 molybdenum silicon layers, that require defect tolerances under 0.2 nanometers. Tokyo Electron executives told Nikkei Asia in April 2025 that China's in-house metrology tools still fail at sub-angstrom calibration for mask alignment. Meanwhile, domestic photoresist makers like Jiwa Chemical have yet to produce EUV-compatible polymers that can meet yield variance thresholds for mass fab deployment. And even if LDP works, achieving synchronized throughput between etching, deposition, and inspection remains an unsolved integration challenge. The State Council's most recent funding allocation, $9.3 billion across 4 pilot lines, suggests commitment, not readiness. As Bernstein's tech strategist Lisa Chow put it, China has proof of concept. What it doesn't have is repeatability under pressure, but that can change fast. Ask anyone who thought Huawei would never make a 7-nanometer chip. So let's get real. If China cuts the cord from ASML and TSMC and then builds something leaner, cheaper, and more energy efficient, what happens to the global tech stack? Think about this. Every AI server, every quantum simulation, every military targeting system in the next decade will depend on who owns the light source. Right now, ASML controls that light. But what if Beijing just cracked the bulb? The blueprint is only the first crack. The next move? It's already being manufactured behind closed doors. So, let me ask you, if China makes EUV obsolete, who rewrites the rules of war, wealth, and power? Drop your answer in the comments. We're glad you're enjoying this video. Please like and subscribe. Check out another video that is now on your screen.